So we need to verify that the vectors A, B and C are non-coplanar, meaning one of the vector cannot be expressed as a linear combination of the other two vectors. And we also need to express another vector D as a linear combination of the vectors A, B and C. Okay, let us begin. Now we'll start with the first part. We'll start with the proof part here. Now we'll try to check that A, B and C are non-coplanar. But to prove this, first we are going to go with an contradiction. We're going to suppose that A vector, B vector and C vector, let's say these three vectors are actually coplanar. That means if they are coplanar, this simply means that we can take any one of the vector and express it as a linear combination of the other two vector. That means we can write it as x times b vector plus y times c vector, and this is going to be our vector A. And here x and y are going to be some scalars. These are scalar values. Okay, now let's substitute the value of A. So A vector is I cap plus 2 times j cap plus 3 times k cap. This will be equals to x times the vector B. The B vector is given as 2i cap plus j cap plus 3k cap. This is going to get added to y times the vector C. So our C vector is I cap plus j cap plus k cap. Okay, now what we'll do, we'll combine all the like terms. We'll also transpose the terms from the right hand side to the left hand side, and that's going to give us 1 minus 2x minus y. This will be the components of I cap. This will get added to 2. We have 2 minus x minus y. This will get multiplied to j cap. Added to 3 minus 3x minus y. This is going to get multiplied to k cap. And this is going to be equals to a null vector. So we have to be a little bit careful here. This is going to be a null vector on the right hand side, because on the left hand side we are operating with vectors. But we know for a fact that the vectors I cap, j cap and k cap itself are non-coplanar. They're non-coplanar, they're orthogonal to each other. So if they are non-coplanar, then the only way this particular equation holds true is if the coefficients of I cap, j cap and k cap are simultaneously 0. That means we have 1 minus 2x minus y. This is going to be equals to 0. Let's label this as number 1. Then we have 2 minus x minus y. That's going to be 0 as well. This is equation number 2. And then we have the third equation, 3 minus 3x minus y equals to 0. We're going to label this as equation number 3. Now, what we'll do, we'll take any two equations at a time and we'll solve for the values of x and y. So let's take equation number 1 and 2. We're going to take 1 and 2. Let's try to rewrite the equation. So 1 minus 2x minus y equals to 0 can be also expressed as 2x plus y equals to 1. This is equation number 1. And then we have equation number 2. Equation number 2, that's x plus y equals to 2. Right. We're going to subtract both the two equations. So 2x minus x, that's going to be simply x. Y minus y, that's 0. 1 minus 2, that will be equals to negative 1. So we have x equals to negative 1. So using x equals to negative 1, we can find out the value of y. Let's use equation number 1. So from equation number 1, we have 1 minus 2 times x, so that's negative 1, minus y equals to 0. So we have y value corresponding to 3. So now we have got the values, y equals to 3 and x equals to negative 1. Fine. Now what we'll do, we will check if x equals to negative 1, when y equals to 3 satisfies 3 or not. Now, equation number 3 is going to be, we have 3 minus 3 times x, so that's negative 1, minus 3, that's equals to 0. Here we have 3 plus 3 minus 3 equals to 0. That's giving us 3 equals to 0, and we know that's a wrong statement. 3 cannot be equals to 0, which means that x and y is not satisfying the third equation. Now that is happening because the vectors A vector, B vector and C vector, these three vectors are non-coplanar. If they were coplanar, then the values of x and y would have satisfied the third equation. Since they're not satisfying, we can say that A vector, B vector and C vector are non-coplanar vector. So we have successfully verified the first part of the problem. The vectors A, vector B and vector C, these are three non-coplanar vectors. Now what we need to do, we are being provided with another vector D, and we need to express it as a linear combination of the three vectors A, B, and C. Fine. Now, in order to express the vector D as a linear combination of A, B, and C, we're going to suppose that let D vector be equals to alpha times A vector plus beta times B vector plus gamma times C vector, where alpha, beta, and gamma, these are three scalars. Now we have suppose that D can be expressed as a linear combination of three vectors A, B, and C. Now we'll use all the values of D, A, B, and C. So now what we'll do, we have we're going to combine all the like terms. So we're going to get 2 minus alpha minus 2 beta minus gamma all multiplied to I cap added to negative 1 minus 2 alpha minus beta minus gamma multiplied to j cap added to negative 3 minus 3 alpha minus 3 beta minus gamma multiplied to k cap, and this is going to be equals to the null vector. Again, since I cap and j cap, since I cap, j cap, and k cap are non-coplanar vectors, non-coplanar, that thus means that 2 minus alpha minus 2 beta minus gamma must be equals to 0. Then we have a negative 1 minus 2 alpha minus beta minus gamma equals to 0. And we have negative 3 minus 3 alpha minus 3 beta minus gamma equals to 0. Let's rearrange the terms. So we have alpha plus 2 beta plus gamma. This is going to be equals to 2. I'm going to label this as equation number 4. Then we have 2 alpha plus beta plus gamma equals to negative 1. That's going to be equation number 3. And then we have 3 alpha plus 3 beta plus gamma equals to negative 3. That's going to be equation number 6. So now we have three equations in three variables, alpha, beta, and gamma. So we can solve this simultaneously to get the values of alpha as negative 8 over 3. Beta is going to be equals to 1 over 3, and gamma is going to be equals to 4. Now this I'm leaving as an exercise for you to verify that alpha, beta, and gamma is indeed going to give us this value. Now that we have alpha, beta, and gamma, we're ready to express the vector D. The D vector in terms of the vector A, B, and C is going to be negative 8 over 3 times A vector plus 1/3 B vector plus 4 times the vector C. Here we have expressed the vector D as a linear combination of the vector A, B, and C.